Back again. Welcome. 6-6. Almost to the end of this chapter. And section 6-6 is called geometric series. And this is similar to, we met an arithmetic sequence, and then we added it up and we called that an arithmetic series. We've now met a geometric sequence, and so now we're going to meet a geometric series. And basically all a geometric series is an indicated sum of terms of a geometric sequence. So let's go ahead and look at an example. So here is a geometric sequence. So if you were just given the sequence and asked to determine, is it arithmetic, is it geometric, I think you would pretty quick figure out it's not arithmetic because we don't continuously add the same number. And I think you would potentially realize, oh yeah, 3 times 4, yeah, that's 12. 12 times 4, 48. 4 times 4, if you check on your calc, is 192, etc. So you'll notice then that we are continuously multiplying by 4. And so we would say then that the common ratio is 4. So now, if we decide to put plus signs in between these numbers, we have then created what we call a geometric series. And when we put plus signs in between things, means that we're usually interested in figuring out the sum. So similar to what we did with an arithmetic series, we can figure out what's called a partial sum. And so I'm going to say, what if I wanted to know what the partial sum of the first 6 terms of this particular series is? So we'll just count to make sure there's 6 of them. 1, 2, 3, 4, 5, 6. Now, if there's only 6 things, it doesn't hurt too much for us actually to just add them up. But of course that's not normally going to be the case, so I just want to help you find your way into an equation that is actually on your cheat sheet, but sometimes I think it helps to understand, like, why does the equation work. So in order to see how this equation works, I'm going to do something a little bit different. And you know what I'm going to do? Actually, I'm going to write this a little bit smaller. So bear with me here for a second. So I'm going to sum the first 6 items. So I have 3 plus 12 plus 48 plus 192 plus 768 plus 3072. So I am actually going to take my common ratio 4 and multiply it by everything in this sum that I'm trying to figure out. So when I take that 4, this 4, and I multiply it by 3, I get a 12. And so what I'm going to do is, instead of putting the 12 here, I'm going to put that 12 over here. So then when I take this 4 and I multiply it by this 12, I get a 48, which I'm going to put here. And when I take a 4 and I multiply it by this 48, I get a 192. And I hope that you'll believe me that all these numbers are basically going to deposit themselves over here. But then there is one other number, because remember, I've kind of shifted everything over 1, and so I also need to take 4 times 3072. And that turns out to be 12,288. So what am I going to do then? Because my idea here is I'm just trying to find a simpler way to add a bunch of a geometric sequence up, or geometric series. So I'm going to go ahead and subtract this new equation I've created from the top equation. And so hopefully you'll see that something interesting happens here. And that interesting thing is that I end up with this 3 minus, there's nothing sitting here, so I end up with a 3. But then all these other positions are just going to go to 0 when I subtract them out. Except for out here, I'm going to have to subtract this 12, 2, 8, 8. And so, if I come down here then and finish my little algebra problem, 3 minus 12, 2, 8, 8. Actually, I'm going to do something a little bit different here, just to make a point. I'm going to go ahead and I'm going to divide across by negative 3 separately to make a point here that's going to lead to my equation. So my sum then is going to be equal to negative 1, and then I have a negative divided by a negative, which is a positive, plus, and if you check on your calc, 12,288 divided by 3 is 4096, which is equal to 4095, which if you were to just add them up individually, you'll find that to be the case. So then what have I actually done here for a formula? And once again, this is on your sheet, so in the end you can really just get it off your sheet. I just want you to see where this is coming from, and I'll show you where it is on the sheet in a second. So what is the formula that I just did? Well, basically I took s sub 6 minus 4s sub 6, which I could write as s sub n minus the common ratio times s sub n. And in the end, it ended up being equal to a sub 1, let me write this and then I'll talk about it, minus a sub 1 times r to the n. Which, if you notice here, this is my a sub 1, and then this is my a sub 1 times r to the n. And I'm going to just take another minute here and do a little maneuvering, and I'm going to actually factor this s sub n out over here. So s sub n times 1 minus r is equal to a sub 1 times a sub 1 to the r times r to the n, which in the end I want to divide this out. So that is kind of a yucky looking equation probably. But if you go on your Regents cheat sheet, you will notice, if you scroll down here, that sitting right here is the sum of a finite geometric series, which is a sub 1 times 1 minus r to the n, all over 1 minus r. So you don't necessarily have to be able to recreate what I just did, but you do need to become aware that this equation is there and available to help you sum geometric series without having to add every single number up. So let me go ahead then and come back here and do an example. So here is an example. Find the sum of the first 10 terms of 2 plus 1 plus 1/2 plus ... And by the way, you could always stop the video and try it on your own and then turn the video back on to see if you are able to do it on your own. So I'm going to go ahead and I'm going to say, hey, this is, well, actually the first thing I'm going to do is make sure that I know what kind of a series this is. And if you notice, I go from 2 to 1, which if you were trying to make this be an arithmetic series, you might say, okay, I'm subtracting 1. But when you subtract another 1, you don't end up at a half. So when I look at this, I say, well, to go from 2 to 1, I divide by 2. Well, then to go from 1 to 1.5 to 1 to a half, oh yeah, I divide by 2 again. So this is a geometric sequence. Now I'm talking about it in terms of division here. So we do want to talk about the common ratio, and in this case, then we are actually multiplying by a half. So when we divide by 2, it's the same as multiplying by 1/2, because that's how we're going to talk about a common ratio. Okay, so using the equation then from the sheet, we need to take a sub 1 times 1 minus the common ratio raised to the n all over 1 minus r. So a sub 1, the first term is 2, times 1 minus the common ratio. Remember, we need to write it in terms of multiplication. So minus 1/2 to the n. So if I'm finding the sum of the first 10 terms, then I'm going to put a 10 up here, and divide this by 1 minus 1/2. So, if you carefully put this into your calculator, you will get something like this. 10, 2, 3 over 256. Now, I could write that as a decimal, but I'm just going to go ahead and leave that as a fraction. Okay, one more example. Find the sum of the first 5 terms of the geometric series whose first term is 2 and fifth term is 162. So once again, this is really about recognition. I mean, we're in the section, this section is on geometric series, but if you were sitting in the gym in June, you need to realize, wait a minute, I have an equation and it's on my sheet, and so maybe just getting that equation onto your paper will get you started. Times 1 minus r to the end, all over 1 minus r. Now, one thing I often do is I might try to at least start filling in some blanks. Do I know what the first term is? And as it turns out, I do. It's 2. Times 1 minus r. Do I know the common ratio? Well, right now that's a problem. So I need to figure out my common ratio. I do know what my n is, though, so I know once I find my common ratio, I'm going to raise it to the 5th power. So I'm going to come over here and I'm going to say, well, whatever is in the 5th position, which they're telling me is 162, is equal to what's in the first position times the common ratio one less time than the position. Because in order to get to the 5th position, I'm going to multiply by the common ratio 4 times. So if I know that there's 162 in the 5th position, and I know there's a 2 in the first position, I can write an equation that has only one thing I don't know. So I'm going to go ahead and solve this equation where I find out that r to the 4th is equal to, when I take 162 divided by 2, is equal to 81. So I am going to take the square root. Am I going to take the square root? If this is a 4, I'm going to take the 4th root of r to the 4th. And so the 4th root of r is r, and the 4th root of 81, and you can do this on your calc by putting a 4 on your screen, and instead of using square root, use the xth root, and you will find out that a 3 comes out. But because this is an even root, it is actually a plus or minus 3. And just to explore that a little bit more, how is it possible the common ratio is a plus or minus 3? Well, in the first position we have a 2. So if the common ratio is a positive 3, 2 times 3 is 6, 6 times 3 is 18, 18 times 3 is 54, and 54 times 3 is 162, as we expect in the 5th position is 162. Well, let's see if a common ratio of negative 3 also works. So 2 times negative 3 is negative 6, negative 6 times negative 3 is a positive 18, positive 18 times negative 3 is a negative 54, and negative 4 times negative 3 gets us to 162. So in this particular situation, we are going to have 2 different answers. So I'm going to start by putting a 3 in here. And if you use your calculator to figure out 2 times 1 minus 3 to the 5th divided by the negative 2, you'll find you get a 242. So that's one sum. But there is actually another sum, and that is what I get when I put in 2 times 1 minus a negative 3. Be careful with your parentheses, to the 5th, all over 1 minus negative 3. And if you use your calc to check that, you will find that you get a sum of 122. So there's 2 different possibilities, because in this case there are 2, there's a positive and a negative common ratio. So that's it on this section. So now you should go to Math Excel for School.com and do the section 6 quiz.